What happens when the element like varies between a negative and
Alright, so we know now that an ion is, you can't see it, but you're lying because there it is. Alright, so an ion is a charged particle, and an ion can be either positive or it can be negative. How do you form a positive ion? You lose electrons, not gain them, lose them. And, yep, if you lose electrons, you become positive. And what's the name of a positive ion? Cation. See? So now we have to do this. Look how cute he is. Okay, and then a negative ion is going to be gaining electrons. It's called an anion. There's a negative ion. Okay? All right, let's take a look at this page that I just gave you, the side that has the three little charts on it. Okay? Carbon, atomic number is 6. I'm going to do this very quickly. You need to have this in front of you. It's a periodic table. And the reason why I want it in front of you every single day is so that nobody's guessing anything. We don't like guessers. All right, 6 protons, 6 electrons, because these are atoms. 666. What group number is carbon in?
14.
How many valence electrons does it have? 4. Define valence electron for me. Go ahead, Trinity.
The electrons on the outermost.
Outermost shell. And how many electrons does an atom want to have in its outermost shell? 8. It wants 8. Okay. So it's either going to gain or lose electrons in order to make that happen. And when one atom loses electrons, somebody else needs to be gaining them, and vice versa. That's the law of conservation. We didn't really talk about that, but in the beginning of the year, I told you that if I dropped $100 on the floor, then somebody's picking $100 up. And all chemistry is making sure everything is balanced. So if I lose $100, $100, somebody else is going to be gaining them. And that's exactly what's happening with these electrons. All right, now if you look at carbon on the periodic table, let's go grab one. The reference tables, here we go. Carbon has 3 possible charges. It really has 4 because the 0 is not listed on there, right? If it's 0, if you just see a carbon written just like this, just like a carbon, boom, like that, and there's nothing in this upper right-hand corner, then this is not an ion, it's an atom. And it's assumed that there's a 0 there. There's no charge. It's neutral. But carbon can also make carbon minus 4, carbon plus 2, and carbon plus 4. So it can make both an anion, which is negative, and 2 different cations. This list is giving us all the possible charges that the carbon can make. So when we go back over to this little chart here, it says, is it a cation or an anion? We're going to write both because it can make both cations and anions depending on who it encounters. I'm just going to write both here. I didn't like the size of that. All right. Go ahead, Kevin. What's up?
If it's like 0 on the right, it's going to have something neither.
Neither. So you looking at the last one there?
Probably the determinant.
Oh, yeah. So down here, this is what Kevin's looking at. See this neon with the 0? That means it's not going to form any ions. It's just going to be neutral. This fluorine can be neutral and it can be a -1. It's 2 different things. It can either be neutral or it can be -1. Nitrogen doesn't know what the heck it wants to do. It can pretty much do anything. Then we had carbon and so on and so forth. All right, so oxygen, atomic number is 8. Protons, 8. Electrons, 8. Group number, 16. I'm going to fly through these. How many valence electrons? 6. Cation or anion? Anion. It usually makes a negative 2. That's what oxygen does. Remember that, because that's going to come back to haunt us. All right, potassium is 19. Does everybody know where I'm getting these numbers from? Okay. Now's the time to shout out if you don't. Here's potassium right there, 19. Okay, 19. Group number 1, valence electrons, uno, and it will make a cation, a +1. Arsenic. What's the symbol for arsenic? AS. It's number 33. Okay, group number 15, which means it's going to have 5 valence electrons, and it will be both. Iodine is number 53. Going too fast for you? Or are you okay? All right, iodine is in group 17, 7 valence electrons, and it will be both. However, 99.9% of the time, iodine is going to be a -1. The one that is listed on top, especially for these group 17 elements, that's where we're going to focus most of our attention. Don't worry about the positives for now. Those generally occur in covalent compounds. We're going to start with ionic. So go with a -1 if you're asked what the iodine or the bromine or the chlorine are going to produce. All right, calcium is number 20. It's in group 2. It has 2 valence electrons, and it will form a cation. Boron is number 5. It is in group 13, 3 valence electrons, and it will form a cation. And then neon is number 10. Group number 18, it has 8 valence electrons, and it will form neither a cation nor an anion because it has its 8 valence electrons. Okay? At this point, you should know what an ion is. You should know if it's positive or negative. You should know how to draw a Bohr diagram. Okay, just pick one. We'll draw a Bohr diagram of it so you know what I'm talking about. Let's do carbon, for instance. When you draw a Bohr diagram, you have the circle in the middle. It's got 6 protons. It will also have 6 neutrons in its most abundant isotope. Okay, I'm getting that from here. 12 is its mass. Okay, so that's 12 minus 6 is 6 neutrons. 12 minus 6 is 6 neutrons. How many energy levels does carbon need to have around it? 2. That one is a perfect circle. I don't know what happened there. All right, I'll use blue for my electrons this time. In the first energy level, you're going to have 2. In the second energy level, you're going to have 4. 1, 2, 3, 4, just like that. So you've got 4 in the outside energy level. That's why carbon doesn't know what to do. Gain 4, lose 4, it doesn't know. Okay, so there's the that's the Bohr diagram for carbon. I didn't do Lewis dot diagrams with you yet. I think I'll wait till after this test and we'll do it afterwards. Okay. Yippee, yippee, skippy. All right. Now let's go down to the bottom. Okay. Chlorine, how many protons? Ladena, how many? Protons. How do you find number of protons? 17. You got it. It's that big black number right there in the bottom left corner. If it has a -1 charge, okay? Did it gain or lose electrons? How many did it gain? 1. So instead of 17, it's going to have 18. Potassium. How many protons? 19. Okay? That means it's positive 1 charge. Keep in mind that sometimes they write +1, sometimes they write 1 plus. It's the same thing. Don't worry about it. They can even write just the plus sign, and that means +1. Okay? So just keep in mind that that sometimes happens. How many electrons does potassium +1 ion have? 18. All right, sulfur -2. Sulfur has 16 protons. If it's a -2 charge, how many electrons does it have? How many? The other way. 18. This chart seems to really like 18. Strontium +2. Strontium has, wait a minute, 38. Yeah. That's what happens when you get old. You can't see the numbers anymore. All right, so 38. And if this is a +2, that means it's going to be 36. All right, aluminum has 13. If it's a +3, that means this is going to be 10. Phosphorus is 15. If it's a -3, then it's going to be 18 again. And silicon, I don't want to tell you what the answer to this one's going to be. Whoever made this really liked that number 18. They should have played it in lottery. This is also going to be 18. Because there's 14 positives and 18 negatives is going to give you a -4 charge. All right, let's do this one. Protons, 56. What symbol is 56? BA? All right. What's its charge going to be? +2. I like it. All right. Protons, 87. FR, francium. What's its charge? +1. Good. 84 is going to be polonium with 86 electrons. -2. 50. Does anybody know what SN stands for? Yeah, stannous, which is tin. That's tin. Okay. 46 electrons, 50 protons. I'm going with +4. It's got more positives than it does negatives. 32 is germanium. -4. 55. CS. +1. And 12 is magnesium. +2. Easy peasy lemon squeezy.